Good morning. In this video, we are going to continue with chapter 4 quadratic equations. Now we are going to see solution of a quadratic equation by completing the square method. For this method, let us consider an example first. X square minus 3x minus 10 is equal to 0. So for this method, first we are going to try to write it in the form a minus b the whole square, after which it will be easy for us to solve it. So for that, the first term x square, we write it as x whole square, which corresponds to a square, minus we are having 3x. So 3x we actually write it as such. We need 2ab. So we'll multiply and divide by 2 over here. So 3x remains as such. We are multiplying and dividing by 2 so that we can bring it in the form 2ab. Now 2 from the formula is there. A is x for us. Now b remains. So 3 by 2 is our b. After this, we are going to add and subtract by b square, because in this question there is no b square, that is 3 by 2 is not there. So when we add and subtract, they both will get cancelled and it will be 0. So both the equations are one and the same. We are just writing it in a different form. Just representation is changing. That's all. So 3 by 2 the whole square minus 3 by 2 the whole square minus 10, we write it as such, equal to 0. So now this is a square minus 2ab plus b square. So this whole term we can substitute as a minus b the whole square, which is x minus 3 by 2 the whole square minus 3 by 2 the whole square minus 10 equal to 0. So the square we leave it as such. The others constants we will solve. So it will be 9 by 4 minus 10 equal to 0. So x minus 3 by 2 the whole square minus 49 by 4 is equal to 0. Now we'll take the constant to the other side. So x minus 3 by 2 the whole square is 49 by 4. Taking square roots on both the sides, we get x minus 3 by 2 is equal to plus or minus 7 by 2. So x minus 3 by 2 can be plus 7 by 2, or x minus 3 by 2 can be minus 7 by 2. So taking minus 3 by 2 to the other side, x is 10 by 2 or 5, or x is minus 4 by 2 or minus 2. So the values of x are 5 or minus 2. We'll get two answers. Let us see one more example for our better understanding. So we have here 3x square minus 5x plus 2 equal to 0, dividing throughout by 3, because we are having a coefficient for x square. We can write this as root 3 the whole square, but it might get a little bit complicated when root is involved. So it is easier to divide by 3 and then solve them. So here we are dividing by 3 throughout. So x square minus 5 by 3x plus 2 by 3 equal to 0. Now x square is a square minus, plus or minus doesn't matter, 2 into a into b. 5 by 3 remains as such. We are multiplying and dividing by 2. Then 5 by 6 we have as b. So we are adding and subtracting 5 by 6 the whole square. Then again, this is x minus 5 by 6 the whole square minus 25 by 36 plus 2 by 3 equal to 0. Let us solve the constant. We will get it equal to 1 by 36. So when we take square root on both the sides, we get x minus 5 by 6 is equal to plus or minus 1 by 6. So x minus 5 by 6 is equal to plus 1 by 6, or x minus 5 by 6 is minus 1 by 6. When we solve for x, we get x equal to 1, or x is equal to 2 by 3. So this is the method of completing by squares. Now we move on to the next method using quadratic formula. This is the most useful formula, and whatever be the equation, we will be able to find a solution using this formula. So let us see how the formula is being derived. Consider the quadratic equation ax square plus bx plus c equal to 0. Same as in completing square type only, we are going to derive this formula. So now we are going to divide by a because it has x square has a coefficient. So x square plus b by ax plus c by a equal to 0. X square plus, we are going to multiply and divide by 2. So 2 into x into b by 2a plus b by 2a the whole square minus b by 2a the whole square. So we are adding and subtracting the square plus c by a equal to 0. So first three terms are of the form x plus b by 2a the whole square. Then we solve the rest of the constants. So solving, we get b square minus 4ac by 4a square because 4a square and 1a is there. So LCM is 4a square. We are going to multiply by 4a over here. Now taking it to the other side, taking square root, this will be plus or minus root of b square minus 4ac by 4a square. Denominator, we can take the root separately. So the answer would be 2a. Now x plus b by 2a is equal to plus or minus root of b square minus 4ac by 2a. So x is equal to minus b by 2a plus or minus root of b square minus 4ac by 2a. So when we write it as a quadratic equation, we get x is equal to minus b plus or minus root of b square minus 4ac by 2a. If b square minus 4ac is greater than or equal to 0, then the roots of the quadratic equation are given by the formula. So it is essential that the root terms under the root b square minus 4ac is positive, because if it is negative, we won't be able to take the root, isn't it? So only for positive answers we are having real roots. So we will consider b square minus 4ac greater than or equal to 0 only. Only then we can use this formula. Okay. Now moving on to exercise 4.2. Question number 1. Find the roots of the following quadratic equations if they exist by the method of completing the square. So 2x square plus x minus 4 equal to 0. Now throughout we are going to divide by 2. We can take the constant to the other side because anyway we are going to end up keeping it in the right side. So then we divide by 2. We get x square plus half x equal to 2. Now we have to add and subtract by 1 by 4 the whole square. So x square plus 1 by 2x plus 1 by 4 the whole square is 2 plus 1 by 4 the whole square. So when we solve this, we get x plus 1 by 4 the whole square equal to 33 by 16. Taking square root on both the sides, we get x plus 1 by 4 equal to plus or minus root 33 by root of 16 is 4. So x is equal to plus or minus root 33 by 4 minus 1 by 4. So x is root 33 minus 1 by 4 or minus root 33 minus 1 by 4. Here minus is not inside the root, it is outside the root. So here there is no problem. Inside the root, you should not have a negative number. That's all. In that case, we won't get any real roots. Moving on to the next one, 4x square plus 4 root 3x plus 3 equal to 0. Yes, when you look at this question, what we find? There's a coefficient of x square, 4. So throughout we have to divide by 4, isn't it? So that way also you can find the answer. But there are easier ways to solve a few questions. This question is one of them. Because 4 is a perfect square, because root of 4 is 2, isn't it? So that is a perfect square. So we can write this in terms of 2x the whole square plus 4 can be written as 2 into 2x into root 3. So 2a and root 3 will be our b plus b square root 3 the whole square. Actually the question is directly in the form a plus b the whole square. Okay, even if you are going to divide, then multiply, then add and subtract by b square, even if you are following the same step, you will get the same answer. Just that for this particular question, that is a lengthy method, while this is an easy method. So we get 2x plus root 3 the whole square equal to 0. Therefore, 2 answer we need to get, isn't it? So 2x plus root 3 equal to 0 and 2x plus root 3 equal to 0. So we are having same answer for both the values, minus root 3 by 2 and minus root 3 by 2. Now we are going to solve by applying quadratic formula. So on comparing the given equation with the general form, ax square plus bx plus c equal to 0, we get a is 2, b is 1 and c is minus 4. So we have got a, b and c. What is the quadratic formula? X is equal to minus b plus or minus root of b square minus 4ac by 2a. So our b value is minus 1. We substitute all a, b, c values in the formula. So we get minus 1 plus or minus root of 1 square minus 4 into 2 into minus 4 by 2 into 2, which is minus 1 plus or minus root 33 by 4. So we get minus 1 plus root 33 by 4 or minus 1 minus root 33 by 4. Now for the next question, again we compare. A is 4, B is 4 root 3, C is 3. So by using quadratic formula, we substitute B as minus 4 by 3 plus or minus root of 4 root 3 the whole square minus 4 into 3 AC by 2 into 4. So minus 4 root 3 plus or minus root of 48 minus 48 by 8. 48 minus 48 is 0. Root of 0 will be 0 only. So plus or minus 0, that's all. So we are left with minus 4 root 3 by 8, which is minus root 3 by 2. Here we are getting only one value because both the two values which are supposed to be there for this quadratic equation are equal. So therefore we write the answer minus 3 by 2 minus 3 by 2. So if we are going to have equal answer, we will get only one value by quadratic formula. So we have to know that when it comes like that, that means they are equal roots. Okay. Now moving on to the third question. Find the roots of the following equation. 1 by x plus 4 minus 1 by x minus 7 equal to 11 by 30. Now here we are not having any quadratic equation. So let us solve the given equation first. So taking LCM over here, denominators directly are LCM. So numerator will be x minus 7 minus of x plus 4. When we solve x minus 7 minus x minus 4 by x plus 4 into x minus 7 is 11 by 30. X and minus x will get cancelled. We'll be left with minus 11 by x plus 4 into x minus 7 equal to 11 by 30. Now, let us minus 11 and 11 will get cancelled. We'll be left with minus 1 over here. So when we cross multiply, we get x plus 4 into x minus 7 is equal to minus 30. Now let us solve this. X square minus 3x minus 28, taking 30 to the other side, plus 30 is equal to 0. Again x square minus 3x plus 2 is equal to 0. We can do this by splitting the middle term, minus 2x minus x. So when we solve, we get the answer x is equal to 2 or x is equal to 1. With this, we have come to the end of the session. We will continue with the exercise with word problems in the next video. Thank you.